Hi and welcome to John's Maths book. In this video, we're going to be looking at the proof of the second part of the Fundamental Theorem of Calculus. If you like the video, then please hit the like button, and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. The second part of the Fundamental Theorem of Calculus tells us that if we have a definite integral over the closed interval AB, so that's the integral from a to b of f of x dx, then we can find the area under the curve, so the area shaded here in red, by subtracting the antiderivative of f of x, that's capital F evaluated at a, from the antiderivative, capital F evaluated at b. Remembering here that capital F prime of x equals f of x from the first part of the Fundamental Theorem of Calculus. To prove this, let's define function g of x to be the integral from a to x of function f of t dt. Function g of x is therefore an antiderivative of the integral of f of t dt between these limits. We also know that many antiderivatives exist for a function. So let's say we have another function, capital F of x, which equals g of x plus c. To see why this is true, let's assume g of x equals x cubed divided by 3 plus 5. If we take the derivative of this, we get x squared. Now let's assume capital F of x is g of x plus 2. So substituting for g of x, that's x cubed divided by 3 plus 5, we get x cubed divided by 3 plus 7. So its derivative, capital F prime of x, is also x squared. So the value of c, shown here in this case, is 7 minus 5, which equals 2. Knowing this, we can say the function capital F evaluated at b minus the function capital F evaluated at a is the same as g evaluated at b plus a constant minus g evaluated at a plus a constant. So the constants c here and here cancel out, and this leaves capital F of b minus capital F of a equal to g of b minus g of a. We know from above that the function g of x is defined as the integral from a to x of f of t dt. So it follows that the function g evaluated at x, where x equals a, is the integral from a to a of f of t dt. So when evaluated, this is the function g of a minus the function g of a, which is 0. Intuitively, we are looking at the area under the curve at x equals a, highlighted on the sketch here, and evaluating the area, which is obviously 0. So we're therefore left with the function g evaluated at b is equal to the function capital F evaluated at b minus the function capital F evaluated at a. So evaluating our function g at x equals b, this will give us the integral from a to b of f of t dt. And we also know that the function g evaluated at b is equivalent to the function capital F evaluated at b minus the function capital F evaluated at a. Finally, if we replace our dummy variable t with x, we finish the proof, which shows that the antiderivative capital F evaluated at b minus its value when evaluated at a is equal to the integral from a to b of f of x dx.